talk about voltage drop today, and we're going to talk about the formula 2 kil over circular mil gives you Vd, and I want you to say it with me now. 2 kil.
2 kil.
Over circular mil.
Over circular mil.
Gives you Vd.
Gives you Vd.
And you can probably remember that from now on, after having said it 4 or 5 times. And now we need to talk about what does that mean. The number 2 stands for single phase. That means the wires go there and they come back, and the whole load goes there and it comes back. Not very efficient. With 3 phase, the load is balanced on the 3 hot wires, and so we don't use 2. So now we need to know what the K is. K is the copper constant at 30 degrees centigrade, which is 10.8. Then we need the current of the circuit. I'm going to say it's 18 amps. And that's actual load of on the circuit. And the length is feet of length of the circuit. And we're going to say that we have a circuit that's 150 feet. A circular mill, we're going to say that wire is measured in circular mill, and down at 14 we have 4,110. Give me the 411. The 4,110 circular mills. But we're not using 14, we're using number 12, which is 6530 circular mills. So now we're going to divide this out. We're going to find out how many volts we just dropped taking this wire there. So we're going to pull out a handy dandy TI 30X2S, so we're going to multiply 2 times 10.8 times 18 times 50, hit enter, divide by 6530, and hit enter again, and we get 8.93. Now what is that? That's volts. That's the number of volts we dropped. Now, let's say that the code book says in a fine print note, or it's now called an advisory, that you may have a total of 5% voltage drop from a main service. So if you have 5% and you're connected to if you're connected to 120 volts and you multiply it times 0.5, oops. 5%? 0.05. I had it right the first time. Sorry. 5% is 0.05. So 120 times 0.05 is what? 6 volts. So even at coming from a main service, that's too much voltage drop. Now, it also says that if you're coming from a sub panel, you never want to allow more than 3% voltage drop, because they're assuming that you've lost 2% in between the main service and the sub panel. Okay? Now, let's assume that we've got 120 volts still. We don't want to lose any more than what? 3%. 3.6. Well, as you know, this is not what we do. We don't go, well, let's put this wire in, we'll put it in this length, and well, let's see what voltage drop we have. Wrong answer. That's not what we want to do. What we want to do is we want to change this formula. Anytime you have A over B is equal to C, you can exchange these two. You can multiply both sides by B and then divide both sides by C. We get A over C is equal to B. So what I'm saying here is we can exchange these two. So if we put in the voltage drop we want to allow and everything else, it will give us the circular mill area of the wire. And if we just look at the code book, it'll tell us what size of wire it is. So now, let's do this the other way around. And we're going to put in 2 kil over Vd is going to give me a circular mill, the actual wire I need. So let's do that now. 2 times 10.8 times 18 times 150, enter, divided by 3.6. Now, since we know that number 10 wire is 10,380, and the next wire's size up is much bigger, like 24 or 26,000, we know this is not going to work with number 10. We're going to have to go up to number 8. Okay? We have to have a wire that is 16,000. 16,200. Okay, whatever. Get up a circular mill wire, a wire with circular mill area of more than 16,200. So, there's one more thing we can do with this. Let's get rid of all this. Now we're going to use three-phase wires this time. We're going to take out square root of 2. We're going to put in, and we're going to take out 2, and we're going to put in the square root of 3. Now, that means we have a three-phase circuit going to someplace. And let's put in some new numbers. And again, let's switch these. Now let's do one first. The square root of 3, which is 1.7321 or thereabouts, times 10.8 times our current. Let's say we're pulling 20 amps and a length of 200 feet and a circular mill area of 10,380. That's the size of number 10 wire, by the way. And so with a number 10 wire, it should be plenty fine. That's way bigger than you need normally for a 20 amp circuit, but we're going out 200 feet. So we're guessing at number 10 wire at 10,380. So square root of 3, hit square root of 3, second function, x squared, enter, times 10.8 times 20 times 200 is equal to, divided by 10,380. Thank you. Now, let's say we have 220 volts. And we're coming from a sub panel, so we can only lose 3%. What's 220 times 0.3? 6.6. Say again? 6.6. Way too much. Right? We're losing too much voltage. Everybody agree with that? Everybody see it? Okay, now let's change this up. We're going to change the formula again, and we're going to go with that other derivation where we go, instead of square root of 3 times kill over circular mill gives one by Vd, we're going to switch these two again. We're going to put in our voltage drop that we want to allow, which is 6.6, and we'll find out what size wire we actually need. So square root of 3, 1.7321, times 10.8, times 20, times 200, enter, divided by 6.6, we find 11,000 what? That's bigger than number 10, smaller than the next size wire. That's a number 8 wire. And if we use a larger wire than necessary, we'll get a lower voltage drop. We'll lose less than 6. All right. I'll be careful not to lose this recording again.